We all knows that till yesterday's class we studied the effect of change of temperature, how it will affect the state of matter. So if you are having, for example, a solid, so by increasing temperature, that is the process we used to call as, what is the process we used to call,
Melting.
everybody?
Melting.
Melting. We people will obtain the liquid. And again by continuously heating, like increasing the temperature, liquid again by melting, that is what we used to
These,
say.
sir,
This we used to call
boiling.
as boiling or vaporization. We used to call as boiling, or we used to call as what? Vaporization. So we people used to convert into what? Gas. Is it clear, all of you? Now, again, same way, reverse process. Reverse process from gas to liquid. What is the process we used to call as, everybody?
Condensation.
Cooling.
Condensation.
Okay, cooling only. So this is what simply we can say cooling. That is what we can say condensation. Condensation will convert into liquid, and from liquid to solid again by what process, everybody? Yesterday.
Freezing.
So that is what we can say, all of you remember, solid to liquid, liquid to gas, continuously I can say, instead of melting and boiling, I'll say, what is that actually? Heating. Is it right or wrong? All of you? Same way, gas to liquid, we used to call it as what? Everybody? Cooling. And
Cooling.
same way, liquid to solid also, what is to call? Everybody? Cooling. Same way, directly solid to gas without forming the liquid. What is the process?
Sublimation.
Sublimation.
Formation of, without formation of liquid, we used to called sublimation. So the sublimation also what we used to call? Heating or cooling? Everybody? We used to call that
Heating.
heating. Understand? Same way, gas to solid directly, we used to call as what? Everybody? Sublimation. We used to call as sublimation. Deposition, which is we used to call as what? Everybody? Cooling. Okay, so till here we studied in till last class. Is it as everybody? Mr. Gokul Ras, Sam, Nivedan. That is what you have to remember it. Now, who else is missing, Mr. Mari? I think everybody is there.
Sir,
Agalya, where is Shivani?
the 2 members missing, I think so, sir.
Yeah. Shivani and as well as Mr. Darun, I think. Darun or Darshan. Yeah,
Darshan.
that's fine. Where is Alvin? Alvin is there. Alvin, good morning. Sanjay, good morning. That is what. So this all the things we studied, this all the effect of temperature, how the effect of temperature will change the state of matter. And we proved that for every substance, 2 points are equal. What is that, guys? Melting point of any substance is equals to what? Everybody?
Boiling point.
Boiling point.
Melting point is not equals
The
to
freezing.
point.
Freezing point.
Melting point
Freezing
is
point.
equals to freezing point, not boiling point. Ennagalya? And boiling point is equals to what? Everybody? Condensation point.
Condensation point.
Understanding? Melting point is equals to freezing point, and boiling point is equals to condensation point. Yes or no? Everybody? All of you. Don't say melting point is equals to boiling point. Is there any substance who is having melting point is equals to boiling point? Any one of you? No. Understand? That is what you have to remember. Now, I'll ask you one question which I already taught you. Let me see how many of you will answer. At a particular temperature, degree Fahrenheit and degree Celsius will become equal. Anybody can tell what? When the degree Celsius...
40 degrees.
Yeah, Celsius scale and Fahrenheit scale are equal. Anyone?
40 degrees.
Minus 40
40
degree.
degree.
40 degree or minus 40 degree? Verify.
Minus 40 degree.
No, I won't say. No. You are not saying correctly. Yes, please. Which temperature degree Celsius and degree Fahrenheit are equal?
Minus 40.
Yes.
Minus 40 degree.
Yes. That is what? Minus 40. Yeah. Verify the notebook. What I have taught you? Minus 40 degrees Celsius. Very good. At minus 40 degrees Celsius, the reading of both what? Celsius scale and Fahrenheit scale are what? Equal. Yes or no? That I have proved or not? Everybody. We have solved or not that one? Everyone should remember that. Okay, guys. Yeah, that is what. So let us see now today's class. What is our today's class means? So effect of change of pressure. Now I want to know how many of you read the book till that page what I told you yesterday. Any one of you? Nobody. I know that. So at least please today, those who are absent in yesterday and day before yesterday, complete the videos fully and read the book till the effect of pressure. Okay. So effect of change of pressure. So let us discuss. Of course, we know that by changing the pressure also, we can change the state of matter. So let us, before going to discuss about it, let me give you one real life example. For example, I want to produce a water vapor. What I have to produce, guys? Everybody? I have to produce what? Water vapor. I am having a water, that is what liquid water. I have to produce a water vapor. Can you tell me, can anybody suggest me what is the way I want to produce a water vapor? On what
The
temperature?
supply.
Gas.
Anybody?
Heating.
Heating,
By
of course. Yes.
boiling.
Yeah, by that time you can see pressure must be what? Atmospheric pressure. What is atmospheric pressure value? Anybody? Atmospheric pressure.
10 power
10 power
5
5.
Pascal.
Atmospheric
1
pressure.
atm.
What is the value? 1.01
10
1 atm.
5 pascals or 1 atm. So at 1 atm, if you notice it, till what temperature we have to heat? Everybody. 100 degrees Celsius to produce liquid water to gas. Yes or no, guys? All of you? Yes. So is
Yes,
there
sir.
one way to produce the gas? Any other way? Anybody can tell? Of course, Mr. Ling is very good. So at the boiling point of water, 100 degrees Celsius, the water will be converting into vapor. Is it right or wrong? By the time 100 degrees Celsius means what is the pressure? At how many ATMs? How many ATMs, Ra? 1 ATM
1 ATM.
or 10 power 5 ATM. Understanding? So sorry, 10 power 5 pascals. Clear, everybody? Understood? Yes? Now,
sir.
I will suggest you another way. Just reduce the atmospheric pressure. Listen, when you want to try in future. For example, you don't have a gas. You don't have anything. Now, if you want to reduce, for example, I want to produce a water vapor, reduce the atmospheric pressure from 1 atm to 0.6 atm. So how much I reduce the pressure? Anybody? 1 atm become 0.6 atm. How much I reduced? Anybody?
0.4.
0.4
0.4 ATMs. Then you know that at 1 ATM, water need how much temperature to produce the gas? Everybody,
100 degree.
100 degrees Celsius. If you reduce the pressure to 0.6 ATM, sir, how to reduce? By using vacuum pump, you can reduce the pressure. Okay. So then, you know, guys, water will converting into gaseous state at 26 degrees Celsius itself. Understand, Mr. Sanjay? Lingesh? Are you clear? If the atmospheric pressure is 0.6 atm, just it is decreases less, then at 26 degrees Celsius itself, the water will be converting into what state? Agalya? What state it will be? Everybody?
Gaseous state.
Gaseous state. Do you all understanding? So, to formation of gas, is it necessary to only increase the temperature? We people cannot change by pressure. Pressure also we can. Understand, Amma? Everybody? Please respond, guys. All of you understood? That is what. So,
Yes, sir.
it is not necessary to only change the pressure, temperature to change the state of matter. Also, we can change what? Everybody. By changing the pressure also, we people can change the state of a matter. But let us see.
Sir, one doubt, sir.
Yes.
Sir, why we are decreasing the atmospheric pressure, sir?
Just I'm saying, Mari, suppose if you don't have a temperature 100 degrees Celsius, but still you want water vapor, then just you reduce the pressure at that particular area, so that at the low temperature itself, water will evaporate into gaseous state. That's all.
Yes, sir.
That is what I'm saying. Because alternative, if you don't have, it's not necessary that if you want to produce the water vapor, Mari, it's not necessary that every time you have to heat only. Do you understand?
Yes, sir.
By reducing the temperature also you can. Are you clear?
Yes, sir.
Yeah, that is what I'm suggesting. Nothing. Are you clear, everybody? Mr. Lingesh, Kishore, Nivedan?
Yes, sir.
Understand? So by
Yes,
reducing the
sir.
small pressure, you can see that boiling point of water came to what? 26, 100 degrees to 26 degrees Celsius itself. Clear, guys? Everybody?
Yes, sir.
Yes, sir.
Nice. So let us see now how to make it. And like now, one more real life example you say. Now, suppose all our team, you people are cooking at the normal surface now. So here normal surface atmospheric pressure is 1 atm or 10 power 5 pascals. So that you are preparing the rice, for example. So I am preparing the rice so that water will take more time to evaporate, so I can cook the rice very easily. Understanding? When at normal level, at a ground level or at a sea level. Okay, now your same team, you people climbed a mountain which is like 10 kilometers above, like long and all. Now you people are constructed a house there above the mountain. Now you started cooking outside like normal bowl and all. Now you tell me, is it possible to cook the rice? That is what my question. Any one of you? Is it possible to cook the rice in normal bowls? Normal bowls in above the mountains. Anybody can tell? Think and tell logically. All of you? Is it possible to cook the rice in the normal bowls? No.
No, sir. Normal bowls.
It is impossible. Why means? Because if you are keep on going above from the ground, atmospheric pressure decreases or increases? Anybody?
Increases.
Atmospheric, understanding? Atmospheric pressure decreases. So atmospheric pressure decreases means, for example, Mr. Lingesh kept 5 liters water with some amount of rice. Understand, Mr. Lingesh? So now what will happen, if you are trying to cook above the hill with like normal bowls, then water will evaporate fastly. Instead of preparation of rice, you will get the ash. Understand? The rice will turns into fried rice. Understanding? Not a fried rice, Ray. It will turns into ash. Clear, everybody? Fried. Rice will become fried. Why? They'll never get sufficient temperature to boil. Understand, Ra, Mari? Sanjay? Clear, Ra?
Sir, then, sir, we can give them sufficient temperature by giving heat. No, sir.
That is what, Mari. Water will evaporate, correct, Mari? At the low temperature itself, water will evaporate because of low pressure. Do you understand? If the
Yes,
rice
sir.
want to boil means it needs to take some time. Yes or no? Because rice cannot be heat directly. Indirect heating. Rice want to cook means first water should heat. Water, from the water only rice will absorb the heat energy. Do you all understand, everybody?
Yes, sir.
Yes, that is the reason. Understand, Mr. Lingesh, Kishore, everybody? So what will happen if you cook in the normal bowls? Listen, Mr. Lingesh, if you cook in the normal bowls, water will quickly evaporate. Then only rice will be there. So rice will be, what will happen? Rice cannot be heat directly. If you heat the rice directly, what will happen? It will turns into what? You put the rice in directly, what will happen? They'll turns into blackish and they'll become ash. Yes or no, guys? Yes, that is the reason. If you are above the mountains, what is used to prefer for cooking purpose? Anybody? What is used to prefer? All of you? Yes, pressure cookers. Understanding? So because what is the importance of pressure cookers? They will increase the pressure more, understanding, so that still the water required more temperature to evaporate. So water cannot be evaporate easily. So pressure cookers increases the pressure more, increases the pressure so that water will never evaporate easily. That is why it will take more time to evaporate. So temperature also increases very, very high, so that the rice also will cook very fastly. Not only rice, you can see in our home, your mother will cook by using pressure cooker only if any kind of substances which will take more time to cook. Have you noticed it? Like general bowls, if you cook it, it will take more time to boil it. But if you put in a pressure cooker, 3 whistles, 2 whistles, she will be getting down. Yes or no, guys? All of you? Understanding? That is the reason. Because pressure cookers will increases the pressure by increasing the temperature also more and more. Still, what is the state of water? What is the state of water? Water will be in what state, guys? liquid state only, so that more faster the food will be cooked. That is the reason biryanis and all you can see more quickly for cooking purpose. We will prefer always pressure cookers only. You know, normal atmospheric, like normal pressure cooker, when it is in second whistle or third whistle, inside almost 16 atms pressure, almost 16 to 20 atms pressure. So very high. So that is the reason if the pressure valve is not working properly, or if you purchase the local pressure cookers, if the valve is not opened properly, then it will damage us severely. If unfortunately it will blast, it will hit like a bomb. Understand? So very dangerous. Pressure cookers are like kitchen bomb, we can say. So when they will explode, we don't know. That is why always we have to prefer a good company one. So that is what you have to remember. Have you understand now? Effect of pressure. Just I'm saying you casual things, this all the things. Are you clear now, everybody?
Sir.
Yeah. Now let us see that we all know three kinds of states of matter. Anybody can tell me what are the three states of matter? All of you?
Solid, liquid, gas.
Solid, liquid,
Solid,
and
liquid,
gas. You all knows the particles. In which one particles are very closely packed? Everybody.
Solid.
Solids, the particles are very closely packed, and liquids little loosely packed, and gases they'll pack what? More loose.
Very loose.
Understanding? So very loose. So this is a solid substance, and let me take this is a liquid and this is the gas. Now liquids are loosely packed, okay, and gases are more loosely packed. That is what we used to call as liquids and gases, and as well as for the first state of matter, everybody, we used to call as solids. Understand? So now we know that the particles of gas are very far apart, which means there is a large gap between the particles or very small gap between the particles. Gas.
Large gap.
Yes. So between the particles, we are having very large gap. Understanding? So the gap is present in gases is more than the what? More than the liquids. So gases gap is more than the liquids, and liquids is more than what? Everybody?
Solid.
Liquids is more than solids. Understand? So when the pressure is applied, you can see the gas particles come closer to one another. When these particles come closer, then the force of attraction, they will come into the play, and this gaseous state change it into what state? Whenever I am applying the pressure.
Sir, then they will decrease the temperature, sir. They will.
Oh, yeah, temperature not a matter, Mari. Just I am pressurizing. Temperature you keep it normally. That's all. Understanding? At normal room temperature. Clear? See, whenever I am studying about the temperature, I may disturb the pressure. Pressure is always constant. Yes or no? Yes. All the temperature effect I told you, pressure is constant. Yes or no? At atmospheric pressure. Yes or no,
Yes,
guys?
sir.
Yes,
Now
sir.
at a room temperature, I am taking everything at a room temperature. So room temperature, I am keep on applying the pressure with the help of piston. Let me take one piston. I am pressing the solid, and with the help of one piston, I am pressing the liquid. With the help of one piston, I am pressing the gas. Now you tell me everything at room temperature. So who can be compressed more? Who will be compressed? Everybody? Gas. Why?
Yes.
Why? Because
It
gas
has more
particles are
intermolecular
having a
space.
what? They're having a what? Large gaps between them, so that if you compress them, the particles will come closer each other. So finally, they will converting into what? Gas will be compressed to what? Everybody? Compressed into liquid state.
Liquid.
Because when the particles are coming closer, the force of attractions increases. So gaseous state changes into liquid state when more pressure is applied. Then if you are keep on increasing the pressure further and further, then liquid will be converting into what? Everybody, same gas
Solid.
will converting into
Solid.
gases. Understanding? So there is a little or negligible impact of pressure. All of you remember, if you take a gas, if you apply the pressure, it will turns into what? Everybody, it will turns into liquid. If I again apply the pressure, gas, again it will turns into what? Everybody, it will turns into solid. Okay, but if I apply the pressure on liquids, if I apply the pressure, understanding, very less impact. Very less impact. Why, guys? Because the spaces between them is what? Less or more?
So
Space.
one doubt, sir.
Yes.
Sir, when we compress the gas, first we are compressing the gas, and after that, when we open out that, it will looks like a liquid, sir.
Basically, inside the cylinder, it will be liquid. But as soon as if you reduce the pressure, again the particles will turn into what? Gas.
Yes.
Understand now? Reverse process, Mari. By decreasing
Yes, sir.
pressure, you put here. By increasing pressure, liquid. Again, by increasing pressure, it will turn into what? Solid. By decreasing pressure, again liquid. By decreasing pressure, again what? It will turn into what? Gas. Understood? But if you
Yes,
take
sir.
the liquid state and as well as solid state, by increasing pressure or decreasing pressure, very, very less impact. So there is no much change in the volume. Why, guys? Anybody can tell me? No much change in the volume. Why? What is the reason?
Less intermolecular space.
Yeah, the molecular space is almost less in liquids and very, very less in what? Everybody. Very, very less in solid state. That is what you have to remember. Is it okay, guys? All of you? Please respond. So,
Sir, what about temperature in this way, sir?
temperature everywhere constant, Mari. When we are discussing about temperature, pressure constant. When pressure constant, pressure we are discussing temperature constant. Can you understand what I am saying?
Then while converting solid to liquid or liquid to gas,
Yeah.
gas to liquid,
Yeah.
we don't need to worry about temperature,
We
sir.
no need to worry about temperature, Mari. Just where is the pressure, that's all. For particularly gas.
Yes,
Understand now?
yes, sir.
So here also, for solids also, very, very less impact. Why very, very less impact? Because particles are what, guys? In solids and liquids? Yeah, they're having a gaps what? Gaps between the particles is less or more?
Very less.
Yeah, gaps between the particles is less. So that is why applying pressure is what? Less impact or more impact?
Less.
Less impact. So no much changes in volume. Please write. Understand, Mr. Sam? No much change in volume. In where, guys? Liquids and solids. But whose volume can change? Anybody?
As
Only gas.
Gas.
So now you tell me, by applying the pressure, only we can change the state of somebody. Who is that? Anyone?
as
Only gas we can change it. But what about liquids and solids? Liquids and
they have
solids?
very less.
Very less. So it is not possible to change the state of matter. So compression of liquids and solids is very, very difficult because they're having negligible impact of pressure on liquids and gases. Please remember that. Compression of liquids or solids is very difficult. What is the reason, guys? Everyone? Difficult due to negligible. Kishore, can you hear me? Yes, please. Negligible impact on pressure. Is it okay, guys? Impact of pressure. So pressure impact only on which substance? Anyone can tell? All of you?
Gas.
Yes.
Only
Yes.
gaseous substance. Now, you can see this is what. So I will say the points you can remember. So that is what you have to remember. Now, for example, you can go back to our textbook. So they have given one activity also you can see here. So effect of change of pressure, they have taken 3. So one is, this is what? Piston cylinder and piston cylinder. You can see here. So they have taken what? Let us see that. So we have already learned that different in various states of matter is due to the difference in the distance between the constituent particles. That is only what we used to call chemistry word. Intermolecular. What is to call?
Intermolecular space.
Intermolecular space.
So what will happen when we start putting pressure and compress a gas enclosed in a cylinder? Will the particles come closer? Do you think that increasing or decreasing the pressure can change the state of matter? Yes. Increasing or decreasing the pressure can change the state of matter, but only which state? Mostly it will state? Only it will change the gaseous state. Understand? So here they have taken a gas. What is that gas means? You can see here, carbon dioxide gas. What gas they have taken here, everyone?
Falling carbon dioxide.
No, they have
Carbon
taken they have taken a gas carbon dioxide. Understand, Amma?
Okay, sir.
So they compressed it, they compressed it, they compressed it. But here, no liquid will form. Why? Carbon dioxide is a what? Actually, it is the, everybody, sublimate product. So that without forming the liquid, directly it will form into what? Everybody.
Gas, solid.
Will form the solid CO2. Solid CO2 name. What is the name of the solid CO2? We used to call it as
Dry ice.
dry.
Dry ice.
Understanding? So you can see applying the pressure and reducing the temperature can liquefy the gases. Okay. So that is what you have to remember. Some people are making noise. And have you heard of solid carbon dioxide? They are asking. Yes. So it is stored under high pressure and solid CO2 gets converted directly into gaseous state on decreasing of pressure to how much, guys? Decreasing of pressure to how much? 1 atmosphere without coming into the liquid state. So this is known as, we used to call, that is the reason solid carbon dioxide we used to call as what? Everybody?
Dry ice.
Dry
Dry
ice.
ice.
Understanding? So if you want to form the dry ice, all of you remember, at normal temperature, what is the state of carbon dioxide, everybody? All of you?
Yes.
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 So if you notice it, if you want to form the dry ice, all of you remember, so basically at pressures below 5.3 atms and the temperatures is above, like you can say, CO2 changes from solid to a gas at what temperature? Sorry, at
By
what,
decreasing the pressure.
by decreasing the pressure. Means in the sense of, basically carbon dioxide will be in a gaseous state at what pressure, everybody? What is a normal pressure? Normal pressure is how much, Amma?
10
Atmospheric pressure 10,
Yeah,
10
1
per
atm or 10 power
1
5
atm.
pascals. At 10 power 5 pascals and at room temperature. All of you remember at what temperature? Room temperature.
Room temperature.
Understanding pressure, the CO2 will be in a what state, everybody? CO2 will be in a, yes,
Gas
please,
state.
gaseous state. Ellame clear? Understood? Purima?
Yes.
Now, if you want to form a solid dry ice, keep it in mind, you have to increase the pressure and same way as well as we have to decrease the what? We have to decrease the temperature also. Now, if you are having a textbook, all of you, check it. I think, yeah, page number, your textbook, I don't know exactly, but you can see that formation of, like you can take a freezing point of dry ice if you put. So at minus 76 degrees Celsius, all of you remember, freezing point of carbon dioxide, if you notice, if you
Sir,
notice,
one doubt, sir.
yes, Mari.
So then from liquid to gas, we need to change from solid, from gas to solid, we need to convert it now, sir.
Yes.
For that, we need to increase the temperature, increase the pressure, and decrease the
Decrease the
temperature.
temperature. Alternative. Understand, Mari? By decreasing,
Yes.
increasing pressure, that is what? By
Sir,
applying
but
the
why, sir,
pressure.
we need to bring the temperature, that phenomena here? You told that we no need to
Yes, Mari,
change any
listen
temperature.
now. Listen now. For example, if you keep on increasing the pressure, so it may take more time to compress the CO2 gas. Understanding? Dry ice. Clear? Okay. So one
Yes, sir.
atm to, if you keep on increasing more and more pressure without, by keeping the temperature constant. Clear? By keeping
Yes,
the
sir.
temperature constant, it will take more atmospheric pressure. More pressure is required to form the dry ice. But if you want to form the dry ice fastly, by increasing the pressure and at the same time, if I reduce the temperature, very quickly I will get the dry ice. That is the reason I will do it. Understand, Mari? Clear?
Yes, sir.
Yeah, that is the reason. According to our
Sir,
convenience.
but actually, when the pressure increases, the
If you
temperature
keep the
also
temperature
increases.
constant also we can. But see, now here I am compressing the gas. I am not putting any temperature. You see, by applying the pressure, the particles of matter can be brought closer together. Am I talking about any temperature here? No. But By applying the pressure and at the same time by reducing the temperature, we can liquefy the gases very faster. That is the reason I'm saying. Are you clear?
This says that it can be more faster than
Yeah,
before,
more
sir.
faster than only by keeping the temperature constant. More faster we can. Clear?
Yes, sir.
Yeah. So you know that the freezing point of the dry ice, if you want to form the dry ice, if you keep the temperature minus 78 degrees Celsius, then it will turns into gas or dry ice. It will or 109.3 degree Fahrenheit. If you put the temperature like this, then it will be automatically converting into what it is? Gases. Sorry, dry ice. Understand, Ra? Clear?
Yes, sir.
Yeah, that is what you have to remember. Nothing is that. Clear, everybody understood, Amma?
Yes, sir.
Yeah. So please make it. Any doubt anybody can ask. So if you are just reducing the temperature to minus 78 degrees Celsius, so automatically it will form the what? All of you? It will form the solid CO2. Is it okay, guys? So that is what you have to remember. So from this we can make, so pressure is the effect of state of matter, but with the help of pressure only we can change what, guys? We can change the, what we can change? Only state of gas. Gas. And other than this, we people like solids and liquids do not have much impact. Is it okay, guys, everybody? So we can say that pressure and temperature determine the state of a substance, whether it will be a solid or liquid or a gas. But pressure, there is no much impact on solids and liquids because they're having more strong intermolecular forces and spaces is very less. So who only will shows more impact? Pressure, everybody? All of you?
Gas.
Yes. So
Gas.
write that point. Everybody write it. All of you write that point. Make it. Right. When all of you write, there is a little or negligible impact of pressure on the liquids and solids. There is a little or negligible impact. There is a little or negligible impact of pressure on the liquids and solids. Liquids and everybody. Liquids and solids. Due to this, compression of liquids or solids is very difficult. Compression of liquids or solids is very difficult. Compression of liquids or solids is very difficult. Compression of liquids or solids is very difficult due to the negligible impact of pressure. Due to the negligible impact of pressure. Due to the negligible impact of what? Everybody? Impact of pressure. Now, next write. We can compress the gas particles, gas molecules. We can compress the gas molecules very large. Okay, Lingesh. Nothing. I'm saying that only. I'm speaking only. Book PDF only I'm showing. You can proceed. We can compress the gas molecules. Gas molecules is very large.
So one doubt, sir. Due to this compression of liquids and solids are difficult to.
Because of very difficult due to the negligible impact of pressure. Okay. That is the reason. Next. The compression of gas molecules is very large or very high, because the gas part molecules have more intermolecular distance. More intermolecular distance. Clear, everybody? Yes, all of you? Please respond, Ra.
Yes, sir.
That is what you have to remember. Okay. So you can maintain that. That is what is an example. Now, That one girl is asking one doubt. Sir, can you convert degree Fahrenheit to degree Celsius? He is asking. So let us solve one question. In your book, any one question is there? Anyone can check it and let me know. Well, sir, I think you don't have any degree Fahrenheit, only degree Celsius we have. Is it correct, guys? All of you? Degree Celsius to degree Kelvin. Sorry, Kelvins only. So nothing is over there, Amma. You have to take it like, what is the relation between degree Fahrenheit and degree Celsius? 9/5 into degree Celsius plus 32. Is it yes or no, guys? All of you? For example, what is your body temperature? Can anybody tell me? What is the body
27
temperature?
degrees Celsius. 37
Huh?
degrees Celsius.
Yeah, 37 degrees Celsius. Okay. So 37 degrees Celsius. Let me see how many degree Fahrenheit, which is equals to
Sir,
9/5
97.
into 37 plus 32. That's all. So 39, 37 nines are how much, Amma? 37 into 9, which is equals to how much, guys? Everybody. 333 divided by 5. If you do it, we'll get it 66.6 plus 32 is there. So if we'll add plus 32, how much it will come? Everybody. 98.6 degree Fahrenheit. There is only if you go to hospital, they'll write in degree Fahrenheit this value only. Have you noticed it, everybody? All of you?
Yes, sir.
Understood, Amma? Lakshanya?
Yes, sir.
Yeah, that's all. Nothing is there. Plus 32. Okay. So that is how you have to convert it. Now, if you want to come reverse, you can come like this. F minus 32 into 5/9, which is equals to degree Celsius. That's all. Okay. Because this plus 32 will come this side, minus 32. 9/5 will come this side, 5/9. That's all. You will get it again. Degree Celsius, 37 degrees Celsius. You want, you can do it. Okay. So this is what about it. So all of you till here, everybody must read each and everything. Then only these questions also you must try. Then we will discuss evaporation and factors affecting the evaporation in our tomorrow's class. And how does the evaporation leaves the cooling? Also we'll discuss in the next tomorrow's class. Okay. So this is all about the today's class. Hope you all understand. Anything, anybody having doubt, ask me. And questions also start solving